Good morning, students. There are two types of control system. Hello, students. Today we are going to discuss about control system basics. There are two types of control system. One is open loop control system and closed loop control system. Control systems, two types. One is open loop and the second one is closed loop. The difference between open loop and closed loop system. Consider a system when the input is applied to the system, then immediately it produces output. So the system output depends purely on input. This type of control system is called open loop control system. Then another type is closed loop. If you want to control the system output to the desired value, then we have to go for closed loop control system. So consider a system when the input is applied, then the system produces output. To maintain the output at the desired value, measure the output using feedback element and compare with the input. So based on the comparison, there will be an error that is called deviation from the desired value. So that deviation can be minimized. It has to be minimized using proper control system to produce desired output. So two types of control system, open loop control system and closed loop system. The advantages of open loop control system: very simple and easy to construct, easy in construction, and the output is always stable. The system output is always stable. Then in closed loop control system, the advantage is accuracy. So we can control the system output accurately. Then the disadvantages means it is a complex one. So you need more devices to produce the desired output. This is the one of the major disadvantages of closed loop control system. Disadvantages in open loop control system: output depends only input, so very difficult to maintain the desired output. Now we'll see the overall block diagram of closed loop control system. Overall block diagram of closed loop system. So first start with a system which is to be controlled, the system output we have to control or maintain at the desired value. Okay, so measure the output using measuring device. We can call it as measuring device or feedback element. First measure it, then output of the device is called measured value, and here the input is applied, and this summer is called error detector because it is going to give the deviation from the input and output. So input, or we can say it as desired value. So based on the deviation, input and measured value, we get a error signal. That error is sent to one controller. So the controller takes corrective action to minimize the system. So this is the basic operation and block diagram of closed loop control system. I will explain again. Output is measured, compared with the desired value, error or deviation will be produced. That error or deviation minimized by the controller. This controller is called feedback controller. Then the entire system also called closed loop control system or feedback control system. Okay, closed loop control system or feedback control system. So now I hope everyone is clear about types of control system, open loop and closed loop control system. Then the general block diagram or overall block diagram of open loop control system and closed loop control system. Now we see one simple example. Water level control. Consider a tank. Input flow, assume this is input flow, and in output side there is a one valve and is outflow, and this is inflow to the tank. So our control objective is level control. So we have to maintain the level at constant value. Assume the dotted line is the desired height, or we can say as level. Assume the water is initially at this position. So measure the level of water using level sensor or level transmitter first. Then the measured value sent to controller, which is called level controller. So in the level controller we also mention the desired height or level. So the controller, level controller, takes the deviation by comparing the desired height and actual height. So based on the error signal, it sends the signal to the valve. It sends the signal to the valve. So valve is either open or closed. So the open and closed signal is sent by the controller. So now the error signal, assume it is the deviation from the desired value and measured value. So this is measured value and this is desired value. When the error is equal to 0, when the error is equal to 0, the meaning is desired value and measured value both are same. That is, the output of the tank is measured at the desired value. When the error is less than 0 means negative. That means the desired value is less than measured value. So the level is above the desired tank. So the present actual level is above the desired level. This is the present and this is actual desired value. So when error is less than 0 means the desired measured value is high compared to the desired value. So the controller takes action by opening the valve. So valve, what is the control valve do? Open till the level is reached the desired value. When the error is greater than 0, that means positive error. In that case, the desired value is greater than measured value. So desired value is shown in the dotted line, red dotted line, and this is the actual value when the error is greater than 0. So in the case, the valve has to be closed to increase the height to the desired value. Okay. So by this action, the controller maintain the desired height of the tank. So this is the basic example of feedback control system or application. We can also call it as closed loop control system. So I will explain the operation. The height of the tank, level of the tank is measured using level transmitter. Then the measured value is compared with the level controller. So based on the error signal, it takes corrective action, either open the valve or close the valve to maintain the desired height. I hope everyone is clear about what is control system, types of control system, and applications of control system. Okay. Next, model, mathematical model. What is mathematical model? It is mathematical representation of physical systems. So it gives the relationship between input and output. So it is in either differential equation, then Laplace transform, and other forms also, state space, etc. So what is mathematical model means? The system is physical system represented it using mathematical equations. Why mean what is the advantage? What are all the advantages means? So when we do experiment with the real-time system, it is a time consuming. If there is any fault occurs, it affects the entire system. So we have to rebuild the entire system. But in mathematical equation, by using mathematical equation, if you do any analysis, so if any mistakes happen, only we have to redo it. That's all. So it won't affect the physical system. Then before designing or before implementing any system, so we have to do mathematical analysis. After that only we have to implement in real time. Okay. So for that we need transfer function, the simple way of transfer function of the system. What does mean by transfer function? The definition is Laplace transform of output and Laplace transform of input. The ratio of Laplace transform of output to Laplace transform of input with zero initial conditions. Okay, so this is a general transfer function of definition of transfer function. Laplace transform of output by Laplace transform of input with zero initial condition. So I'll give you one simple example how to find a mathematical expression or transfer function of a physical system. For that you assume mechanical system. So mechanical system, the basic components are mass, dashpot and spring. So mass M, dashpot B and spring A. Consider a simple mechanical system with a dashpot, with this spring and dashpot. This is spring and this is dashpot, and the mass of this system M. Assume a force is applied, which is denoted by F. When the force is applied, there will be a displacement x of t. It is denoted by x of t. So when the force is applied, so the masses exhibit a displacement. So based on Newton's law, we have to form a differential equation first. Okay, differential equation first. So differential equation first எப்படி பண்ணலாம்? How to do the differential equation? By Newton's law. Applied forces equal to opposing forces. So here the only one force F of t is applied. Then when the force F of t is applied, it exhibits opposing forces Fm of t, Fb of t and Fa of t. Okay, in opposing force, so this can be realized as when F of t, Fm of t, opposing force directly proportional to acceleration, which is nothing by d square x of t by dt square. So we can write m d square x of t by dt square. in dashpot directly proportional to velocity dx of by dt, where x is displacement, then b dx of t by dt. In spring, it is directly proportional to displacement, then we can write it as xk. Now the substitute the values in equation 1. In equation 1 is f of t equal to fm of t plus fb of t plus fk of t. Substitute the values: m square dx of t by dt square, then v dx of t by dt, then k x of t. Okay. Now you take Laplace transform, then it will become f of s m s squared x of s b s x of s k x of s. Then consider x of s as common, then ms square bs plus a into x of s. The definition of Laplace transfer function is Laplace transform of output by Laplace transform of input. Laplace transform of output by Laplace transform of input. Okay. Laplace transform of output by Laplace transform of input. So the Laplace transform of output is x of s, input is f of s. We have to find the ratio. So x of s by f of s equal to, then what we will get is 1 by ms square bs plus a. So where mb or mass, dashpot and spring constant. So assume all the values for analysis purpose 1. Then x of s by f of s equal to 1 by s square s plus 1. So this is the mathematical model or transfer function of the given mechanical system. So by giving the various input to the system, so we can analyze the output variation. So this is the major advantages of finding the mathematical model for the analysis purpose. I hope everyone is clear what is transfer function, what are all the basic components of mechanical system, and how to derive a simple transfer function for a simple mechanical system. Okay, is it clear? Fine. Hello students. Today we are going to discuss how to find the overall transfer function of a given system using signal flow graph. So the representation of system in different types, either in block diagram format or in signal flow graph format. So today we are going to discuss about the system represented in the form of signal flow graph, and we are going to find the transfer function of the overall system using signal flow graph analysis method. So first, signal flow graph. Okay, to find the transfer function of signal flow graph, transfer function, we need gain formula, Mason's gain formula. Example, it is represent TF equal to 1 by del summation of K, Pk and del. So developed by the Mason, then it is, and the transfer function is 1 by del summation of K, Pk, del. So this is the formula used to find the signal flow transfer function of the entire system using signal flow graph method. For this analysis, consider a simple system. It is represented in signal flow graph. So the node 1 is input and node 5 output, C of S. Input is R of S, output C of S. So the system first the value between the nodes also given. So assume the system is represented in signal flow graph form. So based on the formula, the transfer function is 1 by del summation of K, Pk, del K, where P is forward paths, where C is forward paths. Forward paths means it starts from 1 and ends at last node 5 without any repetition. So it travels from 1, 2, 3, 4, 5, the nodes not to be repeated. So in this, the forward path start with first P1. It consists of nodes 1, 2, 3, 4, 5 and the corresponding gain G1, G2, G3, G4 and the corresponding graphical form. So it consists of node 1, 2, 3, 4, 5 and it's the second part 1, 2, then 3, it is takes in the another direction. So 3, 4 and 5. So now 1, 2, 3, 4, 5. Now you got clear about the second forward path G1, G5, G3, G4. So the overall gain G1, G5, G3, G4. So two forward paths. Okay. So and its corresponding gain value. The next one we have to find out is there is any individual loops. Any individual loops. So in this system we have to find out is there is any individual loop. Loop means the starting point and end points must be same. The nodes not to be repeated. So here from 2, 3, 3 to 4, again 4 to 2. So it is a one loop. And another loop is here 4, 5 and again 4. This is the another loop. Okay, it is shown in the red color. So the loops, first loop is, it consists of nodes 2, 3, 4 and again 2. So mention 2, 3, 4, 2. Corresponding diagram 2, 3, 4 and 2. So the gain values, mention it. Then finally the overall gain of the loop is minus G2, G3, H1. Now the second loop is 4, 5, 4. So the nodes are 4, 5, 4. The graphical part is 4, 5 and again 4. So minus H2 in feedback, here G4. Therefore, the overall transfer function is minus G4 H2. And next we have to find out is there is any loops which is not touching. That means not part, entirely different. So in this problem only two loops and their corresponding nodes are 2, 3, 4 and 4, 5, 6. So both the loops are shared the node number 4. Therefore it cannot be considered, comes under non-touching loops category. Therefore in this problem there is no non-touching loops. Okay, there is no non-touching loops. So in previous step the number of forward path k is 2. How many forward paths? P1, P2. Therefore 2 forward paths. The k represents number of forward paths. Therefore the transfer function is 1 by del summation of k equal to 2 pk del k. Okay, substitute, expand this one. So p1 del 1, then p2 del 2. Already we got the value for p1 and p2. We need to find out del 1, del 2 and del. So how to find del? The formula to find is 1 minus sum of individual loops plus sum of two non-touching loops minus etc. So this is the general expression for del and we have to repeat it till the possibility of non-touching loop combination. So in our problem del is 1 minus sum of individual loops. That means 1 minus sum of L1 plus L2. Okay, now you substitute. Now we have to substitute the value for L1 and L2. 1 minus G2 G3 H1 minus G4 H2. So finally what we get? 1 plus G2 G3 H1 plus G4 H2. Okay, so this is the value of del. We got the value of del. So del equal to 1 plus G2 G3 H1 plus G4 H2. So del 1 there. We got the value of del. So as per the expression transfer function, we got del P1 P2. Next we have to find out del 1 and del 2. What is del 1 means? Del 1, actually the 1 is first forward path. So we have to find out value of del for first forward path. Del 2 means del for second forward path. So for del formula, general del formula, we have to apply for forward path 1 and forward path 2. So for del 1, consider the first forward path which consists of nodes 1, 2, 3, 4, 5. If there is any part of the graph is not touching the first forward path. We have two loops 2, 3, 4, 5, 2, 3, 4 and 2, 4, 5, 4. Both the loops are part of the graph. Therefore, there won't be any non-touching loops of not part of the first forward path. So in that case, 1 minus the del formula, how it goes? Sum of individual loops, sum of two non-touching loops, three non-touching loops. So in the first forward path there is no part of the graph. Therefore the remaining parts are 0. Therefore the final value of del 1 equal to 1. Similarly, consider the second forward path. Here the second forward path also, it consists of 1, 2, again 3 in this another direction, 4 and 5. So in this case also there won't be any separate loops which is not part of the second forward path. Therefore the value of del is 1 minus 0. Therefore del 2 is also 1. So we got del 1 and del 2 values also. Now substitute in Mason's gain formula to find the transfer function. 1 by del summation of k pk del k general formula. As per our problem, k equal to 2, therefore p1 del 1 plus p2 del 2. Substitute the value here. First the del value, substitute del value and p1 p2 del 1 del 2 value. So the p1 value is g1 g2 g3 g4. Kindly check it. g1 g2 g3 g4 multiplied with del 1. Del 1 is 1 plus g2 g5 g3 g4 p2 value, del 2 value is 1, the whole divided by del value. So del value is 1 plus g2 g3 h1 plus g4 h2. Kindly check. This is the del value. So we got the overall transfer function of the system. We got overall transfer function of the system. So I hope everyone is clear how to find the transfer function of the system when the graphical representation of the system is given. So using signal flow graph by applying Merson's gain formula, we can able to find the overall transfer function of the system. So I'll summarize the procedure once again. For the given example, write the Merson's gain formula first, then Merson's gain formula, then first find out the first forward path, possible forward paths and its corresponding gain value. Next, individual loops, identify individual loops and its corresponding loop gains. Then apply forward path value in transfer function, expand the formula and identify del 1 and del 2. The formula is similar to del, but we have to apply for first forward path and second forward path. After applying it, so we got the overall transfer function of the system, del value and overall transfer function of the system. Okay, I hope everyone is clear about signal flow graph.